Now that we've talked about structures in Rust, let's talk about enumerations. As structures were great for creating related data and putting them inside a package that we call a structure, enumerations are really useful for grouping related things. For instance, if you have a structure and that structure represents an animal and you want an animal type. So the animal type could, for instance, either be a cat, dog, or a rabbit. These types are related to each other. So enumerations are really good at representing related types, such as, for instance, cat, dog, and a rabbit or a snake, for instance. So the way to create enumerations in Rust is with the enum keyword. As you can see at the bottom of the screen, you can create a simple enumeration called animal type in here. And you start the definition by typing enum, the name of your enumeration, and then your enumeration values in there. Or the values of an enumeration are actually called enumerations themselves as well. So let's go ahead and create an enum in here. And we say animal type. And the name of an enumeration you can see in here is written as Pascal case. So you don't type animal type in here with snake case. So the name of the enumeration always has to be Pascal case. And the cases inside your enumeration themselves, they also have to follow the Pascal case naming convention. So we say dog, cat, and then we can say rabbits, for instance, okay? So this is how you would create a very simple enumeration in here. And I believe actually if you name it incorrectly, you will get a warning. You can say it should have upper camel case name. So it's called upper camel case. I thought it was called a Pascal case. I think Pascal case is actually upper camel case. So that's how you would create your enumerations. After creating an enumeration, you can create an instance of your enumeration simply with the let keyword. So you can say let fluffy, excuse me, is animal type, and then you would say dog, like this. So using this syntax with a double, double columns in here. So that's how you would create an instance of your enumeration, in this case, dog, or you could say cat as well in here, or a rabbit, okay? So that's how you would create instances of your enumeration. So if you want to compare instances of your enumeration with, for instance, if you want to check if Fluffy is a dog, you can use a simple if statement, though it's not recommended, but you could actually do that. In particular cases, sometimes in your functions, you may want to compare an instance of an enumeration with another instance of that enumeration using the if statement, and that's completely fine. And you can do that. You can say if Fluffy is equal to animal type dog in here, and you can see we say then Fluffy is a dog. And let's actually bring up our terminal in here. Okay. Let's go in here and see. There we go, animal type. And implement 0 partial EQ might be missing for animal type. So that's fine. I mean, partial EQ, we're going to implement stuff like that later. So you can actually derive that for your enumeration. So you could go in here and say derive, and you can say partial EQ in here. Okay. And derive, it really helps if I write it correctly as well. So you could derive that implementation for your enumeration. We haven't really gone into derive so much. We just looked at derive of debug in the previous chapters when we're talking about structures. But in here, if you want to be able to compare an instance of your enumeration with another value inside the enumeration, you have to derive this partial EQ trait for your enumeration. But let's not go too much into that because we're going to talk about traits in a separate chapter. But for now, if you want to be able to use the if statement to compare your enumerations with an instance of an enumeration, then you need to derive this particular trait for your enum. Okay, so I said that when we were talking about comparing an instance of your enumeration with another value inside the enum, I said that it is not recommended to do that. And that's simply because in this case, there is no else statement, for instance. So if Fluffy is a dog, then we're doing this logic. But if it's not, we're doing nothing. In most cases, in programs that you write with Rust and other programming languages such as Python or Swift or Dart that do support enumerations, you want to use something called a switch case. In Rust, this is called match. So it's pattern matching, and it will allow you to basically look at, for instance, this Fluffy as an instance and compare it with all available and all possible cases that this Fluffy can actually be, because Fluffy is an animal type. It is not a dog. Its data type is animal type, because animal type is actually the enumeration data type. Fluffy could either be a dog, cat, or a rabbit. At runtime, this may not be completely this information may not be completely visible to your application or even to you. You may get an animal type coming from somewhere and you may not know what it is. So in order to detect what it is, you can use match in order to do basically kind of like more fine-grained if statements without actually writing if, okay? So the way to write match is writing the match keyword, and then you say Fluffy in here, and you can see the suggestion by GitHub Copilot is actually right on the spot. The way to write it is that you put match, name of your variable of type enum, curly brackets, and in there, then you specify the various values that your Fluffy variable can be, in this case, animal type dog, cat, rabbit, and then specify what you actually want to do when that case is true. So in this case, dog is going to be true, so woof is going to be printed to the console. So if I bring up the terminal, you can see then woof somewhere printed to the console, if you can find it right there. Okay, and these warnings are there because the variants cat and rabbit are not being used at the moment. So we're getting quite a lot of warnings for that, but that's quite all right as well. So pause the video if you want to have a look at this match statement in here. Okay, and I usually what I do in these cases when I see some instructions provided by an instructor like myself, for instance, I like to experiment with the code. So I like try to remove these. I was like, okay, what happened? Then there's a missing match arm. So I really think it's good that as you're watching these videos that you take a look at the code that I'm writing and then pause the video and go and do some experimentation on your own so that you learn the code better. So that's really good that we're seeing how we can actually match Fluffy against various types that it can be set to. However, sometimes in your programs, you may not be completely interested in various types of values an enum can be, enum or enum. So in this case, we're interested in Fluffy being a dog, and then we can print woof. But if Fluffy is anything else, then you may want to use a catch-all arm in Rust, as it is called, meaning that anything that is not a dog. So as long as it's a dog, we do this, but anything else, we do something else. And the way to write that is with an underscore and then the syntax, and then you can say print something else, okay? Like this. So this is a catch-all case, as it's called in Rust, and it simply means that anything that is not already handled is going to fall into this case. So if you now bring up our terminal, you can see then something else. Actually, woof is being printed here, but if we change this to a rabbit, you can see that something else will be printed right here. So this is a default case or catch-all case, okay? And it's available in all programming languages that don't that actually have support for enumerations, as far as I know, such as Dart, Python. You also have it in Swift, and you also have it in JavaScript and TypeScript. So that's really good. We've now had a look at a very simple enumeration in here, an animal type, but enumerations are a lot more flexible in Rust than they are in, say, Dart. So you can have associated values with names in your enumerations. As you can see at the bottom screen, you can create, for instance, a shape enumeration that has support for rectangle, circle, point, whatever. And any of those cases themselves, they can actually carry data with them. Now, if you're a Dart developer, for instance, from Flutter, you may be thinking, oh, but Dart also has support for associated values, but not really, because Dart has support for associated values for enums in a constant way, so that you can actually associate a value with an enum, and then you just create instances of that enum in the enum itself. You can't actually create instances of that enum with associated values from outside, and that is quite limiting. But in Rust and programming languages such as Swift, for instance, or Python, you can create, actually, wait a minute, I'm not sure if Python has access to that, but in Swift at least, and Rust, you can have associated values for enumerations. I'm just going to show you how to do that. So let's remove this animal type from here and remove the partial EQ from there as well. Or maybe let's leave the partial EQ. Not sure about that. Let's remove it for now because we don't need it right now. Okay, let's go ahead and create an enum in here. We'll call it shapes. Okay, so the point of shapes enum is to define various shapes that we can have. So we have rectangle and then circle, and let's just leave it at that. So let's say circle and rectangle. Okay, but we don't need a triangle for now. So a circle in this case, or a rectangle in this case, you can see it can have width and height. Okay, so we can go ahead and add width as F64 in here, F32, and then height as F32 as well. Okay, so this is a rectangle, and a circle can have, for instance, a center, which can be its point, and it can also have a radius. So in here we have a radius, and then we can say center, and this could be basically a point. Let's see here. Okay, this point we can actually go and define this point, but for now we could just say the center is F64, F64. We could change these as well to F64, so it's more unified. Basically, all the floating point values in here are F64 instead of a mix of F64 and F32. Good stuff. So now we have our shapes enum. As you can see in here, circle and basically enum case has it with itself a radius and a center, which it itself has a tuple as F64 in here. So this is like you're creating an enum case, which in itself is kind of like a structure. It has properties. It has two fields, namely width and height, and they have their own data types. Circle in itself is kind of like a structure, which has a radius property and a center property, which itself is a tuple. So enums, as I mentioned in Rust, are very powerful, and they can be very complicated if you actually have a look at their implementation and definitions sometimes. So how do you go ahead and instantiate an enum that has associated values? So let's just go ahead and do exactly that. Let's go and create a rectangle. So let's say rectangle, okay? And if you'll see here, a rectangle case in the shapes enum has a width and a height. So we say shapes, and then double columns, and then we say rectangle in here, and then width. Let's just say the width is 3, and the height is 4. Okay, so that's how you would create a rectangle instance of your shapes enumeration with its width and height associated values. All right, this is really this is the same syntax that we use for creating instances of a structure. So this shouldn't be that alien to you by this point. Okay. Okay, good stuff. Now we've talked about creating instances of our enumerations with associated data, but how do you compare instances of an enumeration that has associated data with values of that enumeration, such as a rectangle or a triangle or a circle, for instance? So if you get an instance of shapes inside a function of yours and you want to see, is this a rectangle, you can use the if-let statement. So if you say if-let shapes rectangle, and then you would put some variable definitions in here, width and height, and then you would say it's equal to rectangle, then you can grab the values of width and height. So you say width is, and then say height is this, and then you specify the width and height, for instance, like this. So this is the general format of doing pattern matching with if statement, which is basically if let, and then you specify the shape that you're looking for, rectangle. You specify the name of the variables inside that rectangle, and they have to match exactly the names as specified in the enumeration itself. So these are not name like placeholders. So you can't change this to W, for instance, and you can't change this to H. You're actually more than welcome to go ahead and do that. Just pause the video and do some experimentation on your own. But these names have to match the names as they're defined in the enumeration itself, in Rust at least, okay? So that's comparing enumerations with associated values using the if-let syntax. Now, you may also use the match statement for enumerations with associated values. So if you go in here and say match a rectangle, okay, we can go in here, match a rectangle, okay? And you can see in here, you can do the exact same format that we did before inside our if-let. So you say shape rectangle, width and height, and then you specify a function in here, okay? And you say print width and height. Say width is, and then height is, and then we specify our width and heights. And then in here, we're using that default arm that we talked about inside enumerations to print not a rectangle in any other case where the rectangle is not actually a shapes rectangle, okay? So if I run this code, go to the terminal, you can see what we're getting in the console. It says width is 3 and height is 4, as you'd expect it to say. Now, inside your enumerations, you can also use tuples. So tuples were structures. As you can see in here, center is an example of that. So it is an example of a tuple which has two fields, but they're not named. So they're both floating point 64-bit values, but they don't have names. So this is basically the X and the Y. We don't have to say that. That's usually the way a center is specified, X and Y. Okay, so you can see in here we have, we can change our code. So if we remove the circle, we can say we have a rectangle in here. Okay, that has F32 and then F32, and then we have a size for instance. Okay, and then we can say we have a circle which has F32, 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 which could be its center point of X, Y, and it could be its radius specified like this. And for the rectangle, this could be the starting point of it, so the X and Y, the top left point of the rectangle, and then the size of the rectangle as well. Okay, so this is an example. Let me actually delete the code down here. This is an example of creating an enumeration where you don't want to specify basically the values for, the names of your fields. Okay, and size could as well in here be basically a structure in here. So you could say struct size. Okay, and then you could say width and height, and let's change these to F32 and F32 as well. Okay, and now your enumeration of shape is in place basically. Okay, now that you have that, you may want to create an instance of this shape, for instance, a shape of rectangle. How do you do that? You don't have the field names anymore, but we've already looked at tuples, and you know that the creation of a tuple is also very, very simple. It's pretty much like instantiating a structure without specifying the name of the field. So let's go ahead in here and say, let's a rectangle is shapes, and then we create a rectangle. I don't want to take the suggestions from GitHub Copilot because we want to write it ourselves a little bit. In here, the first parameter to the rectangle is the X point and then the Y point of top left side of the rectangle. So let's just say 1.0, and then we say 2.0. And then we have the size parameter, and the size is a structure which has two properties, width and height, which need to be named. So in here, we need to go ahead and create a size. Width is, let's just say 3, and height is 4. So this is how you would create an instance of that rectangle, which is a combination of tuple and a structure, basically. Okay. Now, if you have such an implementation where you have an enumeration with tuples, which you can see a rectangle is a tuple which has a struct in it, how do you actually do matching with an if statement? And it's very simple. You can say if let, okay, and we say shapes rectangle. I want to write this code actually myself as well. We know that this rectangle has 3 properties. So it has the X, Y, and a size. So let's go ahead and say X, Y, and size. Actually, the code I'm writing is exactly what GitHub Copilot is suggesting. So it's fine. It's fine. And then you say in size, we have to match that as well with width and height. So width and height. And then we say if that is equal to our rectangle, then we're going to execute some code. And then I'm going to take the suggestion from GitHub Copilot. So this is how you would write the code. So you would say if let shapes of rectangle, and then you put your variable placeholders for your enumerations. How do I say it, for the enumeration tuple X and Y, and then for size you have to unwrap the size, as you can see in here, with its properties of width and height with the curly brackets, as we've seen earlier actually with the if let statement for enumerations with a structure inside them. Okay, now if you want to also use match, you can go ahead and do that. So you can say match rectangle in here. Okay, and you could actually do the exact same code as we saw earlier. You can see with the shapes rectangle, X, Y, and size, width, and height, and do some code with it. Otherwise, use the default ARM to print some other statement to the console as well. Okay. Now, you could also have implementation blocks on top of enumeration. So here we have an enum which is called shapes, and you could go ahead and create, for instance, an implementation block for this shapes that, for instance, calculates the area of each one of these shapes. So if you go and say impl shapes, and then we create a function in here, which, oops, that was actually amazing. It did suggest exactly what I wanted to implement. But I say fn area, and then we take a reference to self. So as you remember, if we take a reference to self, we're creating an associated function, which is called a method. It's operating on self. It's not operating on shapes itself. It's operating on an instance of shapes, okay? And this guy can return an F32, okay? And then you can see the suggested code is matching self. If it's a rectangle with its x and y in size, then the area is actually the size, width, and height. So the x and y are going to be ignored in here, okay? And if it's a circle, we have x, y, and then the radius. And you can see radius is being multiplied twice by 3.14, which is our pi, okay? So now you have your area. So now that we have an instance of a rectangle, we can go ahead in here and say rectangle.area. So let area, and then we can print it to the console, println area is, and then we say area, okay? So let's go ahead and have a look at the code and see the area for our rectangle being printed to the console. Could not compile Rust due to previous errors. So we have some errors. Let's go ahead and see if we can fix them. Variant is never constructed, okay, XY. I don't actually see any errors in here, so let's compile the code again. I'm gonna delete what's specified in there in the terminal. And let's run our watch again. Cargo watch, project root does not exist, pwd. We're in Rust crash course. Let's go to Rust crash course again in here and run our cargo watch. Okay, so how many errors do we have? Clippy all, 3.14 radius. So we're getting an error in here. Approximate value of F3264 const pi found. Okay, so there is a constant in here. You can see that we can import this pi actually in here and basically use that. So instead of using a 314 in here, we could use that pi value. So this is actually an amazing suggestion by Clippy, telling us that 314 is already a constant that is defined somewhere else. So we should be using that. So we could go ahead and do that, but I don't think it's necessary right now. Okay, so let's leave it the way it is right now. For the next section, we don't have to have this particular enumeration in here, so I'm just going to remove the shapes. I remove it from here as well, and then we can remove pretty much all the code that we have in the main function as well, so we end up with a clean canvas. All right. So match in Rust is actually an expression, and this is something that I completely love about match in Rust. This is something that Swift has completely missed, in my opinion, at least, in that match in Rust is an expression, meaning that it can return a value. And not that only it can return a value, but it can evaluate to a value, because switch statement in Swift, for instance, as well, it can return a value, but in itself is not an expression, meaning that in itself it cannot become a value. But match is different in Rust, and I'm going to show you how. So let's go ahead and create an enum in here, which is called pet. So we're going to say enum pet, and then we have cat, for instance, and then we have a dog with names. Okay. Now we can go ahead in here and say, okay, let Fluffy is a pet cat with a name Fluffy. All right. Now, if you want to, dependent on whether this is a cat or a dog, but you can see both of them have a name. How do you, given a pet, how do you extract its name? So this is something that you can use match for. So you could say, let's name is match of Fluffy. So you match Fluffy against something, and then given the pet cat's name, you actually return the value of name from the match. You don't have to type return, but if you just specify the name in here, this name will be returned from the match and assigned to name in here. Okay, so if you were to say, for instance, in here 10 and in here 20, then this value would then by default become an I32. But since you've defined the name here to be returned from your match statement, then Rust Analyzer understands that the result coming back from match is actually a string, which is going to be placed inside this name variable. So then you can say println hello, and then you specify the format, and then you would say name. Okay, let's have a look at the terminal and see what we're getting as a result. Hello Fluffy in here. So this is how you would basically use match as an expression instead of just a statement in Rust. So Enumerations are really useful. We're going to see more examples of enumerations throughout this course, but there's a lot to enumerations that you can do. You can do, I mean, for me at least, the most important part about enumerations is not just grouping things, but actually matching and doing pattern matching with them using the match statement. So if you're sitting at home or anywhere doing this course, I really suggest that you pause the video right now before moving on to the next section of the video and have a go yourself at Rust's enumerations and pattern matching, and see if you can add some structures inside your enumerations, add some tuples or a mix of both, do some pattern matching, and see if you can extract data from your enumerations before moving on to the next chapter. So I hope you enjoyed this section of the video, and I'll see you in the next one.